I guess. All right, so we have vertices at -2, 0, and 2, 0. Put a couple more tick marks on here since we have to graph it. Nick, what can you tell from having 2 vertices graphed?
You can tell what the center is.
Yeah, what's the center?
0, 0.
So center at 0, 0 in the middle. What else can you tell, Nick, besides the center at 0, 0?
That it's horizontal.
Good. So we know it's horizontal. Which variable goes first if it's horizontal, Nick?
X.
Good. So x goes first because it's horizontal. Center is at 0, 0. So that means the numerators would just be x squared and y squared. Has to equal 1 for standard form. What else do we know, Brendan? That A is 2 because that's the distance from the vertex to one, or the center to one vertex. And where's the A go, Brandon?
It goes underneath x.
Right, it's always in the front. So it doesn't matter that x is first. With the hyperbola, A squared is always in the front. So he said A is 2, so that makes this a 4. So just from the 2 vertices, we pretty much have most of the information filled out. Kate, what else can we find?
You can find b squared if you plug in that point.
Yeah.
Equation.
And that point always, no matter what type of equation we have, whether it's a parabola, a hyperbola, an ellipse, or an I forget, circle, that will always get plugged in for x and y. So it doesn't matter what type of equation you have. If you're given a point and the graph passes through the point, that has to represent the x and y. So 4 is 16 when we square it. 1 squared is still 1. 16 divided by 4 is 4. Taking that to the other side gives us a -3. And we're left with -1 over b squared equals -3. Kate, how do you get b squared by itself?
You can cross multiply and then divide.
Yeah. So cross multiply, divide. We would end up having -1 equals -3b squared. So b squared would be +1/3. So when you plug that into your equation, now we have a 1/3. Any questions about getting the standard form?
I added the 1 over b squared to the other side first, and I got a different answer. Oh, there's a 1, and I had a 0, it equaled in.
Oh, yeah. So yes, equal to 1 for standard form. If it was 0, that would be that degenerate conic. Other questions? So then you were asked to also graph. This one is a little messy because once you start taking the square roots, you don't get nice numbers. Because for b, we have to have the square root of 1/3. What is the square root of 1/3 rationalized? Libby?
Square root of 3 over 3.
Yeah, square root of 3 over 3. So the square root of 1/3 is 1 over the square root of 3, which is the square root of 3 over 3. Libby, how do you find the c value?
You would do a squared plus b squared. Or find the square root of that.
Yeah, so really you're taking the denominators and adding them for a hyperbola, because the foci need to be further away from the center, subtracting them for an ellipse. So Libby, 4 plus 1/3 is?
That would be. You do square root of. Oh, yeah. It would be 4. 0.33, but then find the square root.
4.33?
Sorry. Okay. The C. Well.
She's like, please call on somebody else, Sabrina. Yeah, the square root of 13 over 3. So 4 is 12/3 plus 1/3 gives us the square root of 13 over 3. What's that rationalize? So think you have the square root of 13 over the square root of 3. Brandon?
Square root of 39/3.
Right, square root of 39 over 3. So that really is our C value. Bridget?
I didn't rationalize and I just like I looked at it differently. Would that be wrong?
What do you mean you look at it different?
Like I just said like I had this as like 1 over the square root of 3. So I knew the square root of 3 was less than 2. So I just had it.
It's like yes. All right, so let's go about finish graphing this, making our graph look beautiful.
They made it square root, they made it really complicated to just say a little more than 2.
A little more than 2. So the square root of 3 over 3. Brandon says it's a little more
I'm
than 2.
talking about, I was talking about C.
Oh, C, yes. Okay, I was going to say, 'cause that one, the square root of 3 is a little more than 2. How about a little less than 2? Divided by 3. So a little less than 2 divided by 3 is going to be a little less than 1. So for B, from the center, a little less than 1 up, a little less than 1 down. The square root of 3 is smaller than 1, or smaller than 2. You're dividing that by 3. So something a little smaller than 2 divided by 3 is a little less than 1. I'm going to draw my little box going horizontally through that B value, vertically through the vertices, and then through the center and the corner. Every corner would be my asymptote. There are 2 branches starting at a vertex and skimming along the asymptote, starting at the vertex on the other side, skimming along the asymptote. Kate.
Since they gave you that point 4, 1, can you say that there's another point at 4, -1?
Yes, you
and
can.
then -4?
Yep, because they have to be symmetrical, yeah. So they give you a point at 4, 1. So we would have a point at 4, 1 and 4, -1. Yes, exactly. And then the last part, Brandon said, they made this difficult to think that a number is, what'd you say? A little more than 2. The square root of 39 is a little more than 6 because the square root of 36 is 6. So this is a little more than 6 divided by 3 gives us a little more than 2. So from the center out a little more than 2 in both directions, left and right. The closer that focus is to the vertex means the skinnier, the more narrow the branches are. If that focus continues to stretch out, then our branches get really wide. That's that eccentricity. Questions? So what questions do you have about any of the conics? So just a little reminder about the parabola. If you have y squared, which direction does the parabola go? Jesse?
Horizontal.
Horizontal. Because x squared is the one that we have graphed last year and this year. That's the one that's vertical because that's the function. That's the only conic that doesn't work with the direction that your mind thinks it should. So a horizontal parabola is really y squared. But every other conic focuses on if it's x, it's horizontal. If it's y, it's vertical, except for that parabola. The parabola is the one where you have the square term on the left and the non-square term on the right. So it's kind of separate from the other three because it doesn't have those 2 square parabolas. So in your packet, you already have 12 to 16 complete. The answers were sent from Remind this morning, 3rd period. Please check your answers. Tomorrow's test is 55 points. They'll be asked, I think, to graph 3, maybe 4. And then the other ones are just like that kind of standard form information. 55 points. You will not be told the type of conic you're working with. it'll just say, find the information for this conic, and the information you'll be finding will be listed below, and then, you'll be sketching the graph. So you'll have to know by looking at just the square terms, the type of conic that it is. Or you could go through the whole completing the square and then realize what it is afterwards. I think sometimes you wanna kind of identify the conic first, you know what you're working towards. So please use this time, the 20-ish minutes that you have, ask questions, please, so that I can answer them. I'll be here tomorrow morning, I promise I'm here tomorrow. I'm not going to